day I call and never speak, and you would say that nothing's changed at all. And again, it seems we meet in the spaces in between. We always say that it won't be long, oh, but something's always wrong. Something's always wrong. Something's always wrong. Hey everybody, welcome to this week's edition of Video Notes for Mr. Flugum's Gen Chem class. That's right folks, this is for Gen Chem. If you're looking for the AP notes, they're somewhere else. Alright, so Gen Chem, we're going to be talking about atomic structure and isotopes. And these notes, you guys, will go on page number 16 in your science notebook. Thanks for tuning in. Let's get started. Alright folks, so when we start talking about atoms, let's talk about the particles that make them up. So there's three basic particles in an atom. You got protons, right? Protons, neutrons, and electrons. And you can see there what their charges are, as well as their mass. Now, protons and neutrons are what have all the mass, okay? Electrons are about 10,000 times smaller than protons and neutrons. So even though they have mass, they don't effectively change the mass of an atom. It's kind of like putting the pebble in the back of a dump truck, right? The pebble's there, but does it really make the dump truck any heavier? Okay, so here's the basic structure of an atom, right? You have the nucleus, and in that nucleus you find the protons and the neutrons. And since the protons are there and have a positive charge, and the neutrons have no charge, well, that makes the nucleus the place of positive charge in the electron. The other part is the electron cloud. And basically the electron cloud is the area around the nucleus where you can find electrons. At least most likely. They're there most of the time. Electrons are highly unpredictable particles, and we'll be learning more about them as we go through this unit. So this is the periodic table, folks. Okay, we're going to use it every day pretty much from here on out. And it shows the most common form of an atom. So when you look at a square, the information in there is about the most common type of atom for that element. There's different forms of those elements though. Okay, there's ions, isotopes, molecules, and all varieties of things. Okay, we'll be talking about isotopes here in a little bit. Now the periodic table is arranged by atomic number. So if you kind of work your way from left to right, as we usually do when we're reading, you can see as you go across, it's arranged by increasing atomic number. You may be wondering, why does it have that funky shape? We'll be talking about that. So let's talk about a really important type of atom called an isotope. So you can see here the definition of an isotope. Every element has more than one isotope. Okay? Right here, you can see there are three different forms of hydrogen, right? So the protons and electrons are the same in isotopes. However, there are more or less neutrons, and that changes the mass. Okay? So here's a way of writing these isotopes. Okay? You can see H is for hydrogen, right? And the number on top is the mass. And the number on the bottom is the atomic number. Okay, so you can see here's hydrogen that has a mass of 2 because it has a proton and a neutron. And here's hydrogen with a mass of 3 because it has a proton and 2 neutrons. So when you look at the periodic table, you will see that all of the atoms have averages that are decimals, right? That's because scientists have found the natural abundance of isotopes. So these isotopes, these different forms of atoms, for example, hydrogen here, appear in definite percentages, and scientists have found ways to detect those different masses. Well, what they do is they find those percentages, and then they find the average atomic mass. So in this case, hydrogen's average atomic mass is 1.007. So there's a question for you. Which isotope of hydrogen is the most common? Well, there's 3 different kinds, and here's another way of writing it. You put hydrogen, and then you put the mass after the name of the element. So is it hydrogen 1, which has no neutrons, hydrogen 2 with 1 neutron, or is hydrogen 3 the most common with 2 neutrons? You might be saying, well, what about protons? Can you change the protons? Well, I'll tell you this, folks. It's very rare that elements change protons. Very rare. Okay? In fact, that only happens in rare cases of nuclear decay, where you have an unstable element. Okay? What that does is it changes it into a different element. When you lose or gain a proton, an atom changes its identity. That doesn't change the charge. Okay? So, protons determine an atom's identity. That's a really important thing to know. For example, boron has 5 protons. Okay? If it has 5 protons in the atom, it's a boron atom. If it lost a proton, what element would boron become? And what if a proton is gained? What if it got more protons? What element would it become? Well, look that up on a periodic table. Okay, check it out, and we'll talk about it in class. Again, remember, this is very rare. Well, thanks for tuning in, folks. Hope you have a great day, and I'll see you in class on Thursday or Friday. Bye-bye.